Hi guys, hi teacher, I'm Phatchara Kranmool. Today I will to present about the control of engineering robotics in the model series RLC circuit. Okay, and the first one I will to present about my contents. So I will introduction about the summarized idea, the knowledge of the modeling, about the simulation or anything else. And two, I will to explain about my design and my simulation of the control system for robotics. And three, I will to explain about my system analysis, about frequency domain, set domain, and time domain. And the last one, I explain about the controller design, about the graph of MATLAB, my MATLAB, or the result, something like this. So, okay, to introduction. The control engineering for robotics involve the application of the control theory and technique of the robotics and the model algorithm for the robotics, such as the accuracy, the velocity, something like this. And about the modeling, I will the short explain about the modeling in control of engineering for robotics. It involves the creation, orchestration, and the mathematical or physical representation the algorithm to understand about the analyze and control the robotic system. And the several key they have system identification, and this step is involve the collection data to form the robotic system and using the statistical um, uh, identify the mathematical, the model, and the system identification help to understand the dynamic and the characteristic of the robot, such as the motion, the force, vector, response inputs, something like this. And about dynamic modeling, yes, dynamic modeling in mostly it show on the physical design, but in MATLAB they have to use dynamic modeling to capture relationship between the inputs and outputs of the robotic system over time, and the model incorporate about the principles for physics, yes, it's physics for engineering, and about the mathematical, the physics they use about the kinetic or motion, and dynamics or force and torque, something like this. So the dynamic modeling is understand to the robot's behavior and decide the control. And about the control algorithm is the one's dynamic. I will explain you. The control algorithm is dynamic too, but the control algorithm are designed to the manipulate about the manipulate the system input, or such as the motor, such as actuator motor, motor torque, joint angle, or inside the motor. And keep about the inputs, such as accuracy, the motion, accuracy motion, and stable balance, about the stability of the motor, something like this. And various control strategies can employ, such as proportional, integral, derivative, something like this, on PID controller. Yes. And the simulation and analysis. The simulate the robot behavior and test the effectiveness of control algorithm. It's all for evaluation of the different scenarios, training of the control parameters, and optimize the technique can be employed, fine-tune the control, something like it. And about the optimize and parameter estimation is employ of the fine-tune control and use parameter to estimate about the metric. Yes, calculate the metric. And additionally, its parameter estimate method can be used to define model's parameter and improve the accuracy of the model control algorithm. And the last one, integration of perception and planning. In modeling or engineering control for robotics often involve about the integration with perception about sensing or sensor, something like that, and planning algorithm. And perception model is cooperate the sensor. I will to explain about the sensor, right? Integration of perception and planning is like you can use the sensor to accurate to calculate, to planning, something like this, and the estimate the robot's state and environment of the robot. And its planning algorithm is generate a high-level plan to the robot achieve its objective. And this component is worth training with control model to enable perceive, plan, or act of robot, its environment, something like this. Okay, about the simulation, I put my result in the right hand side about the RLC circuit. So the simulation in the control engineering of robotics, they use computer-based the modeling mimic the behavior. The robotics system is oral engineering researcher take the analyzed. In the short summarize, the simulation is it show about the input result, the output result, what you want, about the stages, optimization of the parameter, and about to simulate play the crucial role in the validating and defining control algorithm. On the physical, the robots reduce the cost and risk associated with real-world experiments. And the control design in control engineering for robotics involve the development of the algorithm and strategy effectively. And the control design is crucial of enabling the robots to perform the task autonomously and efficiently while ensuring the safety performance optimate, something like that. The implementation using MATLAB, Simulink, and Arduino. In MATLAB Simulink, they have the Arduino model to test. Okay, and MATLAB Simulink is the popular software about the popular software in the present because they allow the engineering and researcher to design, to simulate and implement control system. And the Simulink, they provide about the graphical environment for the modeling the dynamics of the robot system and design the control algorithm. And they simulating their behavior is offer a wide range of building the block and lively specifically on Simulink is different to the MATLAB because the Simulink they have the all of the library what you want, but they code by code box something like this and build in the box code. Yeah, and Arduino they have, or on the other hand is hardware platform that consists of microcontroller, sensor, and actuator, and suitable for the real-time control application. It provides a feasible and affordable solution for interfacing with and controlling the robotic system. About MATLAB Simulink, they have the system modeling using the MATLAB Simulink, the robotic system model and selection approach the block to represent such as sensor, actuator, and the mathematical equation. You can put such as transfer function or state space on MATLAB Simulink too. And the control algorithm design, they are developed within the Simulink to achieve specific control objectives such as trajectory tracking or stabilization, whereas control the techniques such as PID controller. About the Simulink and tracing, it's all the simulation to control the system model, and engineers can evaluate the different scenarios, analyze control response, and optimize the control parameter through simulation and code generation and development. The Simulink can generate embed C or C++ code to compatible with Arduino. And hardware integration, the Arduino platform they use interface with the physical hardware component about the sensor and actuator. And the last one is experimental evaluate. The impairment control is staged on the physical robot and evaluate performance, and data can be the correct and analyzed to assess the effective range of the control algorithm necessary adjustments. And about the design simulation of the control system for robotics, I explain about pan input, output, and characteristic. And pan in my model RLC series, it have R is the resistor, I is inductor, and C is capacitor. And the component connect in my series, the pan represent the physical or mathematical model of the circuit that is being the control analyzed. And the input, I have the input in series RLC circuit is the typical the voltage applied to the circuit. It can be time varying signal or a constant voltage that drive the circuit, and the input voltage is the external stimulus that affect the behavior the circuit influence of the output response. And the output in RLC circuit, my series, my modeling is typical the voltage or the current across specific element in circuit such as the resistor, inductor, capacitor. and it represents the response of the circuits upon the input signal. It can be measured to calculate specific the points in the circuit. They using Ohm law or Kirchhoff laws or other circuit analysis technique. And about characteristic in RLC series is various property and behavior that the design respond different input and some important characteristic. The RLC circuit is resonant frequency. About the frequency at which the circuit exhibits the maximum response is occur the inductive uh, reactance equal capacitive reactance, and the frequency response is behavior. The function of frequency is described how to the circuit impedance or voltage varies different frequency, and damping is the measure how quickly the transient response and determine the stability and behavior of the circuit during transient. And the last one, impedance, is compared to value or opposition the flow of the alternative in the circuit. It depends on the frequency and circuit element. It can be inside behavior. And I will describe all the detail of system analysis and response of the system. And the detail of system analysis response about the RLC circuit in the frequency domain, Z domain, and time domain using the MATLAB. And I input about the how to, yes, it's like how to define the parameter. RLC, you can define about the voltage, the accelerate, something like this, and you have input the transfer function to release the Laplace transform, and you relate the Laplace transform or the outer output current. And frequency domain is divide the transfer function to analyze, and Z domain is convert the transfer function, the Laplace domain, to the Z domain using the appropriate transformation. And the time domain is perform time domain analyzing by obtaining the impulse response and step response. Use the MATLAB. And describe all the detail of the controller. I will start about the Z domain. Z domain, we can you can decide the discrete time the controller for the series RC circuit here or the step involved. This decretion is called the continuous time, the model of the series RLC circuit into decreased time. And Z domain transformation, obtain the transformation of the decreased time RLC circuit model in the Z domain. And controller design is designed a discrete time controller such as PID controller or a lead lag controller using the technique like pole placement of frequency response shaping or optimization algorithms. And the controller implementation is designed the discrete time controller in the Z domain using techniques like different equation or pulse transfer function. And about frequency domain controller design is design you analyze the series RLC circuit response the design controller the step. I will put it down in here. The frequency response analysis is determine the frequency response of the series or in RLC circuit using the technique of body pot. Yes, like body pot, Nyquist pot, Nyquist or Nyquist pot, or frequency response analysis through in the MATLAB, and the controller design. Design a controller that meet the design the frequency response specification. Common design include the loop shaping, the phase margin, specification, or the robust control technique like H infinity control. About the controller implementation, is designed the time domain often using transfer function, state space representation, and the last one, state space control design, is equation and design about the controller base, the system state variable. The state space representation is convert the series RLC circuit into the state space representation, which consists the state equation about dx by dt, dx by dt where ax minus bu, something like this, and the output equation is y minus ca for du, something like this. And about the controller design is on state space representation is technique placement of the optimal control or LQR is mean linear quadratic regulator. It can be employed the design of the controller and the controller implementation. It design the controller about you can use the technique like state feedback, closed loop, something like this, state feedback or observer base to control improvement on the system, on the control system. And okay, it's the last presentation. My presentation, I will summarize all of my final project. I use RLC model to refer the modeling RLC series to simulate and analyze to the model can be developed. The various domain include the time domain, frequency domain, and state space domain. And the model is you need to define the circuit parameters such as the resistance, inductance, and capacitance value. Once you have defined the circuit parameters, you can simulate and analyze the circuit behavior using various techniques. And in the time domain, you can use differential equation or circuit simulation to simulate the RLC circuit response to different input. In frequency domain, you can use MATLAB signal processing to analyze the circuit's frequency response such as body part or Nyquist pot. And in state space domain, you can represent about the RLC circuit using the state space equation and analyze the system behavior using control theory and optimization technique. You can use design and implement controller for the RLC circuit using various methods such as pole placement, frequency response, shaping, or the robust control technique. And overall, MATLAB provides a powerful platform. Is powerful platform. It have all of the library what you want. You can modeling the simulating and analyzing the RLC circuit or another. It's all engineer and researcher to gain insight into the system behavior and decide the effective control strategy. So that's all for today. Thank you to listen, and I put about the code on my work or my assignment too, so you can open or test it and edit about the value. Yes. Okay, thank you. Bye bye.